Backprop hands us a gradient for every weight, but the gradient only points downhill. How big a step to take, and in exactly which direction, is decided by something called the optimizer. And the choice matters more than you would think. In the backprop video, we pictured the loss as a simple valley in one dimension, but a real network has millions of weights. So think of the loss as a whole landscape, drawn here as a contour map. Each ring is a level of loss, and the center is the goal. This shape is a ravine. It drops steeply from the top and bottom walls, but only gently along its floor toward the center. Our ball starts up here, and the optimizer has to get it to the middle. The simplest optimizer is plain SGD. It just follows the gradient straight downhill. But watch what happens in a ravine. The steepest direction points across the valley, into the opposite wall, not along the floor. So it bounces from wall to wall, zigzagging, wasting almost all its effort going sideways. It barely creeps toward the center, slow and wobbly. The first fix is momentum. Instead of forgetting every step, the ball now carries velocity, like a real heavy ball rolling. It remembers where it has been going. The sideways zigzags point in opposite directions, so they cancel out. But the gentle pull along the floor always points the same way, so it builds up speed. The ball stops bouncing and glides smoothly to the center. The standard amount of momentum is 0.9. The second fix is to give each direction its own step size. Steep directions, like the ravine walls, should take small, careful steps. Flat directions, like the floor, can take big, bold ones. Adjusting the step per direction is called an adaptive learning rate. ADAM is the famous optimizer that does both at once. It quietly tracks two running averages for every weight: the average gradient, which gives it momentum, and the average squared gradient, which sets the step size. Momentum plus adaptive steps in one package. That combination is why ADAM just works on so many problems right out of the box. It is the default that almost everyone reaches for first. Let's race all three at once, from the same start. Watch ADAM in green and momentum in blue glide straight to the center, while plain SGD in red is still bouncing off the walls far behind. Same gradients, same landscape. The only difference is the optimizer, and it decides whether you arrive in seconds or crawl for ages. One more name you will see everywhere is ADAM W. It is simply ADAM plus the decoupled weight decay we met in the regularization video, done the proper way. For transformers, it is the default. And there is one more dial that sits on top of any optimizer: the learning rate schedule. Even the best optimizer does better if the step size changes over time. A common recipe is this: start small and warm up, so the first steps do not explode. Rise to a peak while the network explores. Then slowly cool down toward zero, so it can settle gently into the minimum, like cooling metal to set its final shape. So the optimizer is the engine of learning. Plain SGD zigzags. Momentum remembers its direction. ADAM adds an adaptive step for every weight, which is why it is the usual default. And a schedule warms up and cools down on top. We have now covered how a network is built and trained. Next, we change the shape of the problem itself and meet networks that handle sequences with a memory of what came before.